Hello everyone, I'm Christina and welcome to the third video in our A-level Mathematics Calculus series. In this video we're looking at differentiation from first principles and this is part 1. So our objectives for this video are to introduce the definition of the derivative from first principles and to understand why h tends to 0 in our definition of the derivative. So let's first have a look at the definition of a derivative here. So we can see here that our derivative f dash of x is equal to the limit for h tending to 0 of f of x plus h minus f of x over h. So initially this may not mean much. So let's contextualize it with a sketch of a curve. Let's have a look at what we can do here. So this curve is a function, a general function f of x. Recall from the last video that our derivative f dash of x is the same as our gradient function. And our gradient function tells us the gradient of a curve at a point x. Okay, so let's mark on our curve an arbitrary point x here. Let's first try to find the gradient between 2 points on this curve. So to find the gradient in our first video in our calculus series, the definition for our gradient is delta y over delta x. So to do that, we need another point on this curve. So let's think about a point that is h units along our point x. Okay, so the coordinate for that, the x coordinate for that point, will be x plus h. Now, what are the corresponding y coordinates for each? Well, for x, the y coordinate will just be f of x, because f of x is our function. And for x plus h, it's just going to be f of our x coordinate, but our x coordinate is now x plus h. So it's f of x plus h. So now, if we calculate the change in y is y2 minus y1. Our change in x is x2 minus x1. That's our definition of our gradient. So in that case, y2 will be f of x plus h minus f of x over change in x, which is x plus h minus x. Now, what does that give us? We can cancel the denominator a little bit to give us x plus h minus x. That just leaves us with h. And then in the numerator, we get f of x plus h minus f of x. We can't simplify that any further. And that gives us our gradient delta y over delta x. But we want the gradient function at point x. So what we want to think about is our h here should be tending to 0. It should be getting very, very small, infinitesimally small. So in that case, how do we define our derivative at point x? Well, we define it as the limit h tending to 0 of our gradient that we just calculated. And so our derivative f dash of x is the limit of h tending to 0 of f of x plus h minus f of x over h. Now, something to note is that h does not equal 0. Let's quickly have a look at why that is. Let's substitute in h equals 0 into our definition of the derivative. So then that would mean f dash of x equals f of x plus 0 minus f of x over 0. The numerator is just f of x minus f of x over 0. Well, the numerator is just 0, and the denominator stays 0, so we get 0 over 0, but that is undefined. So h cannot equal 0, but it is tending towards 0. Okay, so in the next video, we're going to go through some examples of applying this definition of a derivative from first principles.